A scalar measurement is a quantity that only has a magnitude. Some examples of this is distance, time, mass, and speed. A vector is a quantity that has a magnitude and direction, which is displacement, velocity, acceleration, and force. Distance is a scalar, and it's the amount of ground an object has covered. Displacement is the overall ground an object has covered. Average speed is a scalar, and it is distance traveled over the total time elapsed, and it's measured in meters per second. Average velocity is a vector, and it's displacement over time elapsed, and it's measured in meters per second. An instantaneous velocity is the velocity of an object at a specific point in time. For example, that would be on like a number line or that. Acceleration is the velocity of an object at a specific point in time, and the unit is meters per second squared. Free fall is when gravity is the only acting force on an object, excluding air resistance. And then the unit is mg, which is the weight of gravity in mass times the acceleration of gravity. An example of an object in free fall would be an apple falling from a tree. In physics, the apple would have no air resistance and fall at 9.8 meters per second, which is the acceleration of gravity. There's 3 ways to accelerate in a car. You can accelerate speeding up, slowing down, which is putting on the brakes, which is decelerating, and changing your direction. The frictionless cart is at a position of 0 in our little real-life example. When the cart starts moving, the distance has now increased 4. When I push the cart back, it goes back to the original position, and the overall change of position or displacement is 0 meters. In the world of physics, free fall is when an object is falling and gravity is the only acting force on it. Free fall excludes air resistance. I have a 200-gram weight, and when I drop it from a height of 2 meters, it will fall 9.8 meters per second squared. It'll accelerate 9.8 meters per second squared per second, and the weight of gravity is 200 times 9.8. A real-life example of acceleration is a car. This car is frictionless, and it can accelerate 3 different ways. It can accelerate, it can decelerate, and it can also change directions at a constant velocity. These dots represent the car's position over time. Maybe I can edit it out. Okay. So, at this point in time, the car is... When the car was at a constant velocity, it traveled the same amount of distance per second. When the car was accelerating, the distance it traveled per second increased. When the car was decelerating, over here, the distance per second decreased, which meant it was slowing down. The more often the dots, the increase of speed, the less often means a decrease in speed. When the dots are equally spaced apart, it's at a constant velocity. This is a position versus time graph, and the slope can tell you the velocity. Right now the velocity is constant because it goes up at a constant rate. This is a velocity versus time graph. The slope tells you the acceleration at the certain point in time, and the area between the slope and the x shows you the displacement, so the total position related to the direction. And the acceleration, this is an acceleration and time graph, and it is accelerating, increasing acceleration, and the slope shows the rate of change in the acceleration, and the area, which would be under here and here, shows the change in velocity. When the velocity of an object changes, it is accelerating. Acceleration is the rate of change of the velocity over time, and an increasing speed, decreasing speed, and changing direction is the acceleration. The three main kinematic equations you use to solve for displacement, velocity, and acceleration. The displacement equation is missing final velocity, and its change of x equals initial velocity times the time plus 1/2 at squared. The velocity equation is missing change of x, and its velocity equals acceleration times time plus the initial velocity. And the acceleration equation is missing time, and its velocity squared equals the initial velocity squared plus 2a change of x. And these are all of the terms with what they stand for.
Is an external force that causes a change in motion of an object, and it's measured in newtons. Net force is the sum of all forces of an object. Equilibrium is the condition of a system when neither its state of motion nor its internal energy state tends to change within time. Inertia is the resistance of any physical object to change its velocity. Mass is the quantity of matter in an object regardless of its volume or any force acting upon it. It's measured in kilograms, grams, pounds, and ounces, and more. Weight is the force of gravity acting on an object. Tension is the force transmitted through a spring, rope, cable, or wire. Normal force is a supported or exerted force on an object that is connected with another object, so it's like a book on a table. Friction is a force that resists the relative tangential motion, and constant velocity is an object that travels the same distance every unit of time. Newton's laws. His first law is an object in motion stays in motion unless acted upon by another force. The second law is if the sum of forces acting on an object are balanced, then the acceleration of the object must be 0 meters per second squared. And Newton's third law is for every action there is an equal and opposite reaction, and forces always come in pairs. The unbalanced force definition is a force that causes a change in motion. The centripetal force is an object moving in a circular motion with a constant angular velocity with a rate of change and a tangential velocity.
There's marbles, and when you spin it, they don't fall out.
Tangential speed is a linear speed of something moving along a circular path. G's are related to apparent weight, normal force. Apparent weight is how heavy an object is. And then the Atwood's machine demonstrates the basic principle of dynamics and acceleration. And weightless is no force of support on your body. It's technically in free fall. Projectile motion is when an object moves across a curved path with only the force of gravity acting upon it. The first type is shot at a horizontal angle and just hits the floor. The second one is shot at a vertical and horizontal angle, and it goes up and then it lands at the same level. And the third type is when it's shot at a horizontal vertical angle and it lands below them. And then range is the horizontal distance traveled, and the maximum range angle is 45 degrees. And then the launch velocity is the initial velocity of an object when it is first launched. And then the universal law of motion is every particle attracts other particles in the universe with a force which is directly proportional to the product of their masses. and inversely proportional to the square of the distance between their centers. The orbital period is the time a given astronomical object takes to complete in one orbit around another object. And the escape velocity is the minimum speed needed for a force of an object to escape from the gravitational influence of a massive body. Okay, so work is using a force to make an object move a distance. And then energy is stored work. It's like spring energy, potential energy, or kinetic energy. Gravitational potential energy is the attraction between two objects due to their masses. Kinetic energy is the energy of an object due to its motion. Elastic potential energy is energy stored as a result of the deformation of an elastic object, such as a spring or like a rubber band. Internal energy is the energy contained within a system. Positive work is when a force of an object has a component in the same direction as the displacement of the object. Negative work is when the force of a component in the opposite direction of the displacement of the object. And then energy conservation is the reduction in the amount of energy consumed in a process or system. Okay, so a work energy chart represents the amount of energy possessed by an object by means of a vertical bar. And then Hooke's law is the deformation of an object in a proportional to the force causing it. And then a spring constant is the slope of a straight line. It's W versus the x plot. Work done by friction is the friction always works in the opposite direction of the object, of like the direction the object's going. And then the elastic collision is a collision between two objects whose the total amount of energy is the same before and after the collision. An inelastic collision is the collision where some of the kinetic energy is changed in another form. The perfectly or totally inelastic collision is a collision where two objects collide and stick together, and then there are more as one mass. They're like combined as one mass, and the kinetic energy is not conserved. Power is the rate of doing work. Rate of energy conversion. Gravitational potential energy of planetary or stellar objects is the total kinetic energy or stellar objects is equal to minus 1/2 times the total gravitational potential energy. And the escape speed is the circular speed in which a projectile can outrun the gravity. An escaped Earth's pull is 11.2 kilometers a second.
This is a still block and it has a mass, and the only forces acting on this block right now are normal force pushing up from the ground and the weight of gravity pushing down, and that's what the free body diagram is. And a block being pushed, the free body diagram would be normal force up, the weight of gravity down, the force of friction pushing against the person, and the force applied as the person pushing. And in this resolution of vectors example, this is a sine being held up by two strings. And in the free body diagram, there is tension over here, and then the mass of the weight of gravity. And it shows that, and you can find theta and use the x and y axis to solve for force. This is a horizontal launch, and it has no initial vertical component because it goes straight out. In this launch, it is initially vertical and horizontal. At the top of it, it is a horizontal only. And when it's at the bottom and it hits the ground, it is horizontal and vertical. And then this is the starting equation to solve for time. And as we work through it, we get that the total time in the air is time equals 2 initial velocity times the sine of theta divided by g. There are 3 different movements in an elevator. This one is constant movement, where normal force is equal to the weight of gravity and there's no acceleration. This one is accelerating down, where normal force is less than the weight of gravity and it's moving downwards, and it's equal to the mass times acceleration. And this elevator is accelerating up, where normal force is bigger than the the weight of gravity, and normal force is bigger than the weight of gravity, and it's equal to ma.
This is a horizontal unbanked curve where the car is going around a curve, and it is static frictional force provides the centrifugal force keeping the car on the road. And terminal velocity is the final velocity an object can reach in free fall because of air resistance. This is a diagram of an object accelerating down an inclined plane without friction. So the normal force is always going to be perpendicular to the surface, and the weight of gravity is always going to be down. This is going to be theta, the angle of the incline, and it will also be theta right here, which will help you find the horizontal acceleration, which is going to be which is going to be the force sine of theta, and then for vertical acceleration, it's going to be the force cosine theta. And this is going to be the normal force on a Ferris wheel. And at the top, normal force is going to be bigger than the weight of gravity. And at the bottom, the weight of gravity is going to be greater than the normal force. And this is Atwood's machine, and one mass depends on the movement of the other one, which will make them have different acceleration. Movement impulse, momentum impulse, isolated system. In a collision, the total momentum of the two objects before the collision is equal to the total momentum after the collision. Momentum stays the same and is transferred. Conserves quality. Any quality that cannot be created or destroyed. Some examples are energy and momentum. Linear momentum, the product of its mass and its velocity. Linear momentum, the product of its mass and its velocity. P would be momentum, M would be mass, and V would be velocity. Conservation of momentum. Constant momentum if there is no other external forces acting upon the system. Impulse, the product of force multiplied by the time, which would be the change in linear momentum, also in the same direction. Impulse momentum chart. So this is the impulse, but this was the change in momentum at the beginning, and this was the change of momentum at the end. So this plus this would equal the change at the end. Force of impact, the force generated when an object hits another, and force increases when the square of the velocity does. Time of impact is the time it takes for objects to impact. Some examples would be sand in barrels being hit by a car, and bed sheets being hit by a baseball.
This is a roller coaster. Gravity is always down, and there's energy, inertia, and gravity. A car stopping is kinetic to potential energy. The projectile launch at various angles. To get the farthest launch, it's at 45-degree angle, and it can have more distance or more time based on how it's launched. A bungee jump is potential energy converted into kinetic energy when they bounce back. There are 3 types of collisions: elastic, inelastic, and totally inelastic. Elastic energy is preserved and momentum is preserved. Inelastic, momentum is preserved and energy is preserved. And totally inelastic, momentum is preserved, but the max amount of energy lost, the objects normally stick together.